Hello, everyone, and good afternoon. My name is Richard, and you can contact me on GitHub or Twitter at FlyerHCM. And my topic is find and replace code based on AST. So what's AST? AST stands for Abstract Syntax Tree. The AST is a data structure that is easier to understand and manipulate. It represents the code as a tree of nodes. Each node in the tree represents a different structure constructed in the code, such as a class definition or a variable assignment. For example, here I define a class named RubyKaigi with two instance methods, year and location. The right part is the corresponding AST. The class node, for the class node, the node type is class. The rest are class name, parent class, and class body. For the instance method, the node type is def. The rest are method name, arguments, and the method body. So why we use the AST? You find and replace code based on AST offers several benefits over the traditional text-based or regular expression-based find and replace methods. Because AST provides a structured representation of the code, it allows for more precise searching and replacement. For example, when searching for instance of the ports code, it can be challenging to accurately locate all occurrences using the text-based or regular expression-based searches. We want to find all the ports code used in the left part, but not the right part, such as it's not supposed to be in a string or in a hairdog or a method name named custom underscore ports. By leveraging AST-based searching, we can precisely identify all instances of the ports code as intended. Moreover, removing the ports code becomes straightforward using AST. Later, I will show you how. And AST-based find and replace tools are powerful because they can be used to perform complex searching and replacement. It can find hash pair where key and value are identical and delete the value. It can find old hash rocket key syntax and replace with new hash syntax. It can find mini-test setup methods that do not call super and prepend super. So what tools based on AST? In Ruby world, there are several tools available that uses AST for a variety of tasks, including the code analysis, linting, and formatting. Some popular tools include Rig, is a Ruby code smear detector that uses AST to identify common code smears. Rubocop is a popular Ruby linter that uses AST to perform its analysis. Rufo is another Ruby formatter that uses AST to format Ruby code. I have an alternative solution for you called Synvert. This tool enables you to write snippet code to rewrite your source code. I initially developed Synvert to simplify the process of upgrading a Rails project. At that time, I was working on a Rails project that used the version 2.3, and I need to upgrade it to the version 3. The upgrade involved a lot of syntax changes, and it was difficult to manually find and replace all of them. So I created Synvert to help me automate the process, and it worked successfully. Over time, I continued to use Synvert to upgrade the Rails project to version 4, 5, and 6. In 2014, I gave a presentation at RubyKaigi with the title, Write Ruby Code to Change the Ruby Code. That presentation gave a brief introduction to the Synvert and its capabilities. This was the architecture of Synvert at that time. Synvert core uses AST to analyze and transform Ruby code and provides a set of DSS for defining code transformations in a concise and readable way. Synvert snippets is a collection of predefined code transformations. Synvert is a command line tool that reads Synvert snippets and uses Synvert core to automate the code transformation. In recent years, I have been focused on making Synvert more user-friendly and accessible to a wider audience of developers. To achieve this goal, I have been working on improving the APIs and developing a GUI application. The enhanced API of Synvert simplifies the process of writing code snippets, while the GUI applications enables user to use the Synvert without the need for writing any code at all. This means that the Synvert can be used by both experienced and inexperienced developers to easily find and replace code based on the AST. To begin, I extracted 2 gems from Synvert core, node query and node mutations. These 2 gems are designed to provide a specialized focus on querying and mutating code using the AST. So node query defines NQL and node rules to query nodes. NQL is a CSS-like node query language. It's more expressive and powerful. And the node rules is just a hash object. It's simpler and can be faster. Let's see some examples. To find the ports and the P debug code, the above is the NQL dot send, just like the class select in CSS. It is to match the node whose node type is send. And the string in the square brackets is to match node's attributes. Here it matches receiver is new. Message is either ports or P. The below one is node rules. It's similar, but uses hash object. To find 2 string arguments, the NQL is to find the send node, whose message is gsub. The argument's size is 2, and both of the arguments are string node. And we can use to find the hash rocket key. The NQL to find the hash pair node, whose key is a symbol node, and the source code of the key matches a regular expression for a hash rocket key. The node rules can also match a regular expression. And to find the hash pairs where key and the value are identical. The NQL is to find the hash pair node whose key equals to the value. The value in double curly braces will be evaluated. So here it matches the real value rather than the string value. Okay, this is a complex case. To find the mini-test setup methods that do not call super, the NQL query uses descendant and the pseudo selectors, which are similar to the ones used in CSS selectors. It searches for class nodes whose parent class is mini-test. Within each class node, it looks for the def node with the name setup. The pseudo selector not has ensures there is no supernode within the def node. It's important to note that this cannot be accomplished in a single node route. Instead, it needs to be broken down into 3 steps. The first step, it needs to locate the class name or locate the class node. And the second step is to find the def node. And the third step is to verify the absence of a supernode. Find the hash value. There's a helper to query the value of a hash key. The NQL to find the hash node, it can use the status value to check the value of the status key. Here, to check if it is not new. Actually, this is used to check the status key exists. NQL can do much more. I use the rex and the rag to build the lex and the parser of NQL. If you are interested, you can check out the source code on GitHub. So node mutation. Node mutation provides a set of APIs to rewrite the source code based on AST. It tracks the start and end position and the new code to replace and generates the new source code. Here are some examples. The source code is errors at base equal to string other not present. We call replace with original receiver dot add with arguments .0 and arguments .1. So the source code will be replaced with errors dot add with 2 arguments. The first is the single argument base, and the second is the string argument other not present. And the source code is class post inherits from active record base. We call replace parent class with application record. The source code will be replaced with application record. And here is open URL. We call insert URI dot at the beginning. The source code becomes URI dot open a URL. And you can prepend you can use prepend to add a super to the beginning of a setup method, and use append to add a super to the end of the teardown method. And you can also use delete receiver and dot to remove the factory dot, and the source code will be replaced with create user. And the remove method will remove the whole code of the node. Here it removes the whole put statement. Again, we have some helpers for hash node. For example, it replaced the message after commit with, the last argument is a hash node, so the evaluated value is on value of the last argument, which is create. So it replaced with after create commit, and we delete the on pair of the last argument and the comma. So the source code becomes after create commit blah 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 without the on pair. You can use the no query and no mutation outside of the Synvert. Here is an example that demonstrates how to use them to remove put statements. First, we need to include the necessary dependencies. We use the parser gem to pass source code to AST nodes. Additionally, we require parser node ext, which assigns names to the child nodes of the parser node, and require no query and no mutation. Next, we utilize the parser to transform the source code to AST node and initialize a no query with a NQAir string. Then we call query nodes to find the matching nodes. Then we initialize a node mutation object with original source code, and we call the remove method to eliminate the matching node. So by calling the process method, we obtain the updated source code, which no longer contains the post statements. I have created an adapt interface to accommodate different parsers within no query and no mutation. Currently, it utilizes the parser gem to parse the Ruby code into AST nodes. However, it is designed to be flexible and capable of integrating alternative parsers. For instance, I am currently working on a syntax tree adapter. So Synvert offers a set of DSLs built on top of no query and no mutation, which makes it much easier to write code or write your snippet code. It uses within files to find all Ruby files, uses find node to accept NQL string to query nodes, and delegate the remove to the node mutation. You can use other DSLs, like use the if Ruby and if gem to check the dependencies, add file and remove file to manipulate files, add a snippet to add other snippets. It accepts the snippet name, local file, or remote URL. It allows you to write many small snippets and combine them into a bigger one. It also supports view files so that you can write Ruby code in ERB, HAML, or Slim files. Synvert offers a CAI that allows users to execute the local or remote snippet. Okay, at present, I have introduced most of the Synvert DSLs that developers can use to write their own snippet. However, there may still be a learning curve involved in mastering these DSLs. So to provide developer a better experience, I have developed a GUI application to allow developers to use the Synvert without the need for writing any code at all. The Synvert GUI applications supports Windows and Mac OS. It allows you to run code snippet and see the differences between the original code and modified code before applying the changes. This means that you can review the changes individually and decide which ones to accept and which ones to reject. Once you have reviewed the changes, you can selectively apply them to your code base. It provides a feature where you can import some code and the expected output, and it will automatically generate the code snippet for you. This generated snippet can be used to find and replace your source code. It also provides a list of official code snippets that you can select and run. These snippets are predefined and have already been reviewed and tested, so you can be confident they are safe to use. So here is a demo that uses Synvert without writing any code at all. On March 2nd,
2023, I read a tip in Ruby Weekly. Not value.nil is a lot faster than value not equal to nil. It's nearly 5 times faster, so I want to update my codebase accordingly. I opened the Synvert application and copied the code from the tip and paste them into the inputs and outputs. Then I click the Generate Snippet button. After reviewing the snippet, I click the Search button. And Synvert finds all occurrences of value not equal to nil in my codebase. I can selectively apply the change or click the Replace All button to apply them all at once. I can run git diff to view all the changes to my codebase. On March 2nd,
you see that it took about 1 or 2 minutes while I see the tip and apply to my code base. And we don't need to write any code. And you may know that RubyCorp also has a corp to check and fix this issue. Let me take a look. This is not a complete source code. I have removed some unrelated code. RubyCorp is capable of not only identifying the issue, but also autocorrecting it. It uses its own query language in def node matcher to find the nodes that matches the pattern. The node type is send. The underscore ignore the receiver, and the message is not equal, and the argument is nil. In autocorrect method, it uses regular expression to replace the source code with not.nil. This is the Synvert snippet code. It initializes a rewriter with group and name, within files to find all Ruby files, find node with an NQL to find the nodes. The NQL is to check the node type is send, message is not equal, argument size is 1, and the first argument is nil. Then replace the source code with not original receiver .nil. So Synvert snippet is much easier to read, understand, and share. You can simply copy paste the snippet code from everywhere and run it within the Synvert GUI application. I also built a VS Code extension for Synvert. It works the same as the Synvert GUI application. You can use it to run the code snippet, generate the snippet by inputs and outputs, and search an official snippet. There's a Synvert playground. It cannot run the snippet, but it can test the snippet, generate a snippet, and generate AST node from source code to help you play with the AST nodes. In addition to using Ruby, I frequently use JavaScript and TypeScript, so I created the Synvert JavaScript. With this tool, you can write code snippet to rewrite your JavaScript and the TypeScript source code in a similar way to the Synvert Ruby. I have posted some video tutorials on Substack that demonstrate how to use Synvert for specific tasks, such as migrating jQuery and upgrading Rails 4.2 to 5. These tutorials offer a detailed guide on how to use Synvert through a series of step-by-step instructions. Synvert is not mature yet. If you have any issue to write code snippet, or if you have any suggestion or feedback, please do not hesitate to contact us. Thank you.